Okay, girls, so today we'll do the formulas for the sum of a geometric sequence. And the idea of establishing these, or you figuring out why they work, we'll talk about later, okay? But we can talk about r, and we can say that when r is really small, like let's say it's between -1 and 1, let's say it's -1/2, okay, that's the difference each time. When I start at 6, the next term is going to be -3, and the next term is going to be +3 on 2, and the next term is going to be -3 on 4. Okay, I'm just multiplying by -1/2 each time. So what's happening, this is surely closer to 0 than that, is that it's alternating where it is, but they're getting closer and closer to 0. So that's for when r is between -1 and 0. When r is between 0 and 1, let's make it half this time, and I start with 10, I go to 5, and then 5 on 2, and then 5 on 4, and then 5 on 8, and you get the idea, and this number is getting really small. It's closer and closer to 0. So we can actually add up this sequence in a way. It has what we call an infinite sum. We'll do that in a minute. When r is less than -1, then these things go crazy this way. You know, they still alternate sign. You know, if I started with r being -2, and I started with 3, I'd get -6, then +12, then -24, and you can see they alternate sign, and they go crazy big, okay? And then when r is greater than 1, of course there's no negative involved, so they just get really big. These are kind of like the ones we did yesterday when we did that, okay? And then if r is equal to 1, well, that's ridiculous. Then all the terms are the same. Okay. The two formulas for the sum, so when we add up, okay, so this is the sum of the first n terms of a geometric sequence when r is the common ratio, okay? But when r is between -1 and 1, so when it's a fraction, I can use this and I can get a common ratio. I can get a sum. Okay, we'll do some examples. So it says calculate the sum of the first terms of the geometric sequence with t equal 2 and r equals -2. Calculate the sum of the first terms. Oh, I better put something in there. Let's say first 5 terms, okay, of the geometric sequence. Okay, so my formula is s sub n equals t sub 1 r to the n minus 1. This is like bracketed here if you want to think of it like that, over r minus 1. Kind of a wacky formula, but it's on your formula sheet, so you don't need to worry too much about it. So I'm going to say s sub 5 equals 2 bracket -2, I have to put that in brackets, to the 5 minus 1 over -2 minus 1. Okay. I'll grab my calculator. I think I'll be able to see it. I'll go 2 bracket, and I'm going to use my fraction there, and put, you have to use brackets here, you're not going to get it right, -2 to the 5th. I'll get out of there. Oops, minus 1. And I'll go down here and put -2 minus 1. I'm going to go over and end that bracket. I get 22. Well, it's just using a formula. The sum of the first 4 terms of a geometric sequence is 10, and the common ratio is 3. What's the value of the first term? Okay, let's try it. So I have the sum of the first 10 terms, so that's the sum, that's 10. The common ratio is 3, so I don't know what t sub 1 is, but I know that this is 3 to the n minus 1. Oop, 3 to the n, 3 to the 10. All over 3 minus 1. So I'm going to do these brackets first. 3 to the 10 minus 1 divided by 2. So I have 10 equals t to the 1, bracket 2, 9, 5, 2, 4. Now I divide 10 divided by that huge thing, and I get a wacky number. So 3.39 times 10 to the negative 4. Okay, I like it. Now it says calculate the sum of an infinite geometric sequence. So I'm going to use this thing with t sub 1 equal to 3 and r equal to 1/3. So for A, this was B, sorry. So for A, the formula is sub 1 over 1 minus r. That's an easier formula. 3 over 1/3, oops, 1 minus 1/3. I could easily do that by hand, but I'll do 3 divided by 1 minus 1/3, 4.5. And B says calculate the sum of an infinite geometric sequence, and it gives you that. So I know t sub 1 equals 8, and r equals, you can see it's 1/2. So I'm going to use my formula. I'm going to do s sub infinity equals 8 over 1 minus 1/2. That's 8 divided by half, or 8 times 2, which is 16. Okay, the problems that you need to do are here.